there, but I didn't see my error. Okay, and I will show you. All right. So I knew. How do you like my little drawing? Okay, little holes. All right. So I knew the diameter was 2. That I need to use radius.
I forgot to use radius. I just used diameter.
Yeah, okay, so it is about radius, and I knew that the area of the roof was 30 feet, okay, and 30 square feet, I guess. And I did my computation. It was like, okay, the area was 1 pi. The area when the radius was 1.5 would have been 2.25 pi inches, okay. And then I knew that it would be 3 squared is 9 pi inches. Okay, it was like, all right, inches. And then the first time I went through this, oh, I know what I did. I added up the area of all the little holes, and I got 12.25 pi. And then I multiplied 12.25 pi and got 38.48 inches. Now the first time I did it, I still don't, I'm not quite sure, I know what I did. I divided this by 12, and I should have divided by something else.
144.
Why would you divide the 38?
Because I'm comparing 2 different units. I have inches and feet. Okay? And so the first time I did this, doesn't it make sense? Well, I'm going to divide it into feet. Divide by 12. But there's a problem there.
It's squared.
It should have been square feet. And so I should have divided by 144. That's where I made my mistake. Stephen?
In the beginning, couldn't you have just changed it on the spot? Like you could have changed 6 feet to, it was 60 inches, and it's 5 feet to 60 inches.
Absolutely. Yeah, there are many different ways to have approached it. Yeah, I mean, you could have done it that way. And I was just showing you how I did it. Let's see, Jessica just did it, and she converted hers, I believe, right at the beginning to 30 feet. It was squared, and she knew it was square inches, which would be 144. Okay, that's a common error. Very common, very easy error to make. I made it myself, and it was like, oh, I forgot to convert into square inches. So just kind of remind yourself of that, and you might want to make a little note somewhere in your notes. Remember to check units of measure, number 1, and if we're talking about square, measurements that you're converting into whatever it is, square. Elif.
But what's the answer?
The answer was, I think, 0.01 chance. So it was 38.4 what? 48 divided by, she converted the 30 into 30 feet.
Yeah, what if we got 0.89?
0.89. So think about that. Think about your answer first. 0.89 is what percent?
0.89%.
I got that answer.
0.89. It's 1%, and yeah, that would be right. 0.1%. Okay, and that's actually what you had said, isn't it? Okay, but if you had said you needed to make that conversion and understand that it was 1% chance, or as a probability it would have been 0.01.
I had a question about the website.
Okay, can you hold on that second?
Yeah.
So you're saying that, I think what I did wrong was like I took 30 feet squared and just divided it by 12.
Yes.
So I would have needed to divide it by 144.
Correct.
Okay.
Okay? Because you had 30 square feet, but you're talking square inches, so it would have been 12 by 12 was 144.
Where'd the 38.48 come from?
The third, this is the area of all the of the little holes, and when I added them all up, I had 12.25 times 3.14. So think about it. 3 times 12 is what? 36. So you're multiplying by 3.14. So it's a little bit bigger than that. Okay. All right. Question about the website.
Yeah, is there any way that you can disable the emails that we get every day?
Yes.
Yeah, I get like
Because
6
we get
of
like
them.
3 or 4 emails every single day.
Okay, I will check into that. Okay, And what I'm trying to do is I'm putting, Jess has agreed to, we're gonna try it, have it here so that it's focused right here, and I'm hoping that it will be a little bit clearer, the image when you look at it, okay? Because sometimes, you know, as I said, it's a work in progress, and I'm hoping that this will be user-friendly to you. Okay, so are we ready to roll? Take out your notes, and I'm gonna give you some more notes. Okay, so we have talked about two ways to solve systems of equations. The first one being, well, that's one way. The first way we did on our calculator using what?
Linear or the intersection.
So we graphed it, right? So the first way is graphing it. The second way is substitution. And the third way is going to be by linear combination. When we're in linear combination, we want to make sure that we are in, pardon me? I'm teaching it to you right now. I'm actually hoping that maybe you had this as a freshman.
I remember this.
Okay, I mean, you should have had this as Algebra 1. This is a review of Algebra 1. Okay, so in this particular case, just look at this, Eli. I have x plus y is equal to 3, and x minus y is equal to 1. And if I combine them, I can see that my y and my x are eliminated. What I'd like you to do is take out your graphing calculator for a second. I want to show you what happens when we do a combination. Okay, so for the moment, we're just going to rearrange this equation and put it into y equals so that we can graph it. Okay, so what I'd like to do is, let's just look at this. Okay, so what would this be if I rearrange equation number 1? It's going to be y equals what?
Negative x plus 3.
Okay, so enter that in.
Wait, enter what?
Hold on a second, I'm looking for a marker. Okay, let's rearrange this. So I have y is equal to a negative x plus 3. All I did was rearrange it so I can put it in as a graph. And the next one is going to be a negative y is equal to 1, well, about 1 plus 1. How do I get rid of the negative 1, negative y? I'm multiplying the whole thing by a negative 1, so I will have what? Y, and this will be what? A negative. So let's graph those two equations. And I'm going to put in a negative x plus 3. And the next one is going to be what? X minus 1. Okay, just hold those for a second. And I'm going to go back. So I'm getting ready to, I'm going to look at the graph in a second. But let's use a linear combination. And I know that if these two, if I combine them, these combine, and I have 2x is 4 equals 4, x is equal to 2. Let's graph x is equal to 2. That's the third thing. We're going to enter that as our third equation. X is equal to 2.
How do we graph
sorry,
x again?
I can't do that. All right, I'm bad. Let's look at, can we use this now to go back and do substitution actually. So I have x plus y equals 3. And I know that if x is 2, what will y equal? 1. Let's graph y is equal to 1. Alright. And then graph all 3. Okay? So they all go through that same point. And that's why linear combination works. And in this particular case, it would have been nice if I had just gotten the y first, but instead of the x. But when that is what we're doing when we're doing the combination. The combination works like that. The two of them combine to get that same point. All right? So let's try another one. I'm going to give you 3 examples of these, and the 3 of them are all slightly different. Okay? So in this first problem, I was already in standard form. Okay? Let's look at the second problem. Okay, in this problem, I have 2x plus y plus 5, and I have x plus y equals 4. Is it obvious what I'm going to eliminate?
Nope.
No, I don't have anything there ready to eliminate. In the previous, in the previous problem, did I have to do anything, or was it apparent that I could eliminate something from the get-go? Yeah, the y's. I had a positive y and a negative y. It was very easy to eliminate in this particular problem. In this problem, they're not as, it's not there right away, but I can very easily change my equation by doing what? Multiplying by a negative 1. And if I multiply by a negative 1, is it now obvious that I can eliminate what?
Wait, you multiply just one by negative?
Remember, if I have y is equal to x plus 3, if I choose, for whatever reason the mood strikes me, to multiply this equation by 2, I have to multiply everything in the equation. So I would have 2y is equal to 2x plus 6. Okay, this is the same as that.
I think you have to multiply the top equation also.
No, I just chose 1. Because what I'm trying to do is eliminate them. So I could have chosen the top or the bottom one. It doesn't matter which one I chose to multiply. But I multiplied the bottom one by negative. So I had negative 1 times x gave me the negative x. I had negative 1 times y, negative y, negative 1 times 4, negative 4. Can I now eliminate something? Okay, I can eliminate my y's. And what do I have? Yeah, I'm going to have what? X is equal to 1. This one was a pretty easy one. Yeah?